Dear students, in this session we are going to see interhalogen compounds. Between halogen atoms, common halogens you may be knowing: fluorine, chlorine, bromine, iodine. Between these elements, only two elements get involved in the formation of interhalogen compounds. Usually, among the four, you should know it is more electronegative. Always electronegative. Fluorine. It is less electronegative. And it is larger. It is smaller. So these points you should know. When interhalogen compounds are formed, it is smaller, still larger. This is how it goes. The order of size. Fluorine is smaller, chlorine, bromine and iodine. So it is the increasing order of size and decreasing order of electronegative nature. When interhalogen compounds are formed, usually larger atom forms the central atom. Let us designate larger atom by A and smaller atom by B. So interhalogen compounds are found between A and B. Larger, smaller. It is larger, smaller. More electronegative, less electronegative. So this is how the compounds are always formed. And each halogen combines with another halogen to form interhalogen compound. And it is only between less electronegative and more electronegative. This is how compounds are formed. And the compound may be of the type AB, AB3, AB5, AB7. What does it mean? One element may combine with just one element. Sometimes one may combine with 3, one may combine with 5, one may combine with 7. But usually the less electronegative element forms A. Larger, smaller. Always fluorine should be present as B and not A. Fluorine can never become A. But all others can be depending upon the situations. Alright. Now, between F, Cl, Br and I, between Cl and F, we can get a compound. Between Br and F, yes, between Br and F. Between Cl and F, chlorine fluoride, bromine fluoride, chlorine fluoride. And then it can be between bromine and chlorine. Already we have seen chlorine and fluorine, bromine and chlorine. So BrCl and then ICl. It can be ICl. And it can also be last one, IBr. These are the possibilities. And all these compounds exist. In the case of AB3, we get only limited compounds. What are those limited compounds? To start with, all the three with fluorine: ClF3, BrF3, IF3. ClF, BrF, IF. ClF, BrF, IF. BrCl, ICl and then IBr. This is so. So here CrF3, BrF3, IF3. With fluorine we can get like this. And what else we can have? ICl. Already I got. Then it can be BrF3. It can be IF3. BrF3 and BrF3 we have seen. ICl3. We can have ICl3. So these are the compounds. Others, it is very difficult because between Br and Cl, since the size variation is not so high, that BrCl3 is not possible. The difference goes like this. With the fluorine, always it is more electronegative, very high electronegativity, and therefore with the fluorine, all these compounds can form AB, AB3, AB5 and AB7 can be formed. But with other elements, little bit gap is needed. Therefore, it can form ICl3. All right. Then, in the case of AB5, ClF, ClF5, BrF5, IF5. Only fluorides can form. Only fluorides, ClF5, BrF5, IF5. And in the case of 7, we are getting only IF, large difference. IF, large difference in electronegativity. So this is how the compounds exist. All those possibilities we have discussed, just 3 and then addition only one more. When we go for AB5, all the 3, only those 3. And when we go for AB7, last 2 categories, very larger, very smaller, very high electronegativity, very low electronegativity. Only those 2 elements form interhalogen compounds. So, iodine, heptafluoride, chlorine, pentafluoride, chlorine, trifluoride, likewise. Iodine, trifluoride, iodine, pentafluoride, likewise it goes. So, all these elements you may be knowing how those elements are being formed. Now, during the formation of these elements, what are the important things to be noted? Usually, central atom, central element, central halogen should be larger. That I said already. Then, chlorine cannot form as central atom. Chlorine cannot be here. Chlorine cannot be A. Always other elements, only other elements can be here, because it is more electronegative. Due to the high electronegativity and the smaller size, it can help other elements. Due to high electronegativity and smaller size, it can help other element to show higher valency, higher coordination number. So it increases the coordination number of other elements. All right. Then it can undergo auto-oxidation. For example, 2ICl, iodine chloride, ICl. It undergoes ionization, auto-ionization. How? I plus, less electronegative, larger, it will form plus. And another one, ICl2 minus. ICl, 2 molecules. Only iodine becomes I plus, the rest ICl minus. So, auto-ionization, this sort of ionization is possible with interhalogen compounds, auto-ionization. And if we go in for ICl4 or ICl3 like that, ICl4 we don't have, ICl3, 2 molecules of ICl3, it can become ICl3. One chloride ion can go over here, so therefore it becomes ICl plus ICl4 minus. ICl2. Here it is, ICl2, ICl. Chloride ion goes here with negative charge. Therefore, it becomes ICl2 minus. It becomes I plus in the first case. I plus ICl2 minus. Why minus? It is I plus, it is Cl minus. Here, one chloride ion with negative charge moves over here. Therefore, it becomes ICl2 plus. Here ICl2 minus, here ICl2 plus. And then ICl4 minus. Such auto-ionization is possible, always possible with interhalogen compounds because of the electronegativity difference between the 2 halogens. The less electronegative element which is present at the last may lead to the another molecule to get the negative charge, leaving positive charge in the first molecule. This is how it goes. All right. Then these elements are strong oxidizing agents. They can act as oxidizing agents. That means they can withdraw electron because of the electronegative nature. So these are the important characteristics, and moreover, in the interhalogen compounds, in the presence of alkali, they may form oxohalide and halide. Halide and oxohalides are formed with bases, in the presence of bases. For example, BRF minus, in the presence of alkali, BRF minus, BRF F5, we have seen. Always fluoride can be like that. All the 5 can be, that is more electronegative, fluoride ion. Always it is negative, 5F minus. Remaining Br can be in the form of bromate ion, BrO3 minus, bromate, iodate, likewise. And yet another example, IF, if I go in for IF or ICl, in the presence of an alkali, it will become Cl minus, and I will become hypoiodite. KClO3 you might have heard of. Potassium chlorate, it is bromate. Hypochlorous acid, sodium hypochlorite you might have heard of. OCl minus. It is hypochlorite, here hypoiodite. All right. So with in the presence of alkali, interhalogen compounds can form halide ion. Which one will become halide ion? The more electronegative. Second one, B. The more electronegative one can form halide ion, and the less electronegative one will form halate ion or hypohalate ion. Likewise it is formed. So these are all the important properties of interhalogen compounds. What are things we have discussed? Just let us recollect. Only 2 elements combine. Larger, smaller. Smaller, larger. Larger one will be the central metal atom. Less electronegative, more electronegative. If we illustrate in the form of AB, it is larger, less electronegative. Smaller, more electronegative. Likewise it is formed. So always B is in the form of F. Always. F. And in certain molecules, Br or Cl can form B. In most of the cases, F always negative. In some cases, they can act depending upon the other one. Larger, smaller, larger, smaller, larger, smaller, larger, smaller. Between this larger, smaller, like this. All right. So central metal atom is always larger, and fluorine, only 2 elements are formed between, only 2 halogens are combined, and not more than that. Fluorine cannot act as a central atom, that is, it cannot be a larger one. Due to the high electronegativity, it makes the other molecule to show higher coordination number, and interhalogen compounds can undergo autoionization. The smaller one will become negative charge, higher one by taking one or few more negative ion can become negatively charged ion. Here 2 ICl, among 2 ICl, 1 Cl minus is taken up by this one, therefore ICl2 minus, here I plus. Likewise here, ICl3, 1 Cl minus is being removed, therefore it becomes ICl2 plus, and that Cl minus get attached with another molecule to give ICl minus. In the presence of alkali, they may form halide ion and hypohalite or halate. Usually, smaller one will be halide, larger one will be hypohalite or halate. Then, regarding structure of these compounds, let us go into the structure. Very interesting interhalogen compounds. Only point, electronegative difference and size difference. That's how they form molecules. And then AX, AB we have taken, is it not? AB, let me take in the form of AB. AB3, AB5 and AB7. 4 types we have seen. AB molecule is getting involved in sp3 hybridization. sp3. Next to that we can add one by one. sp3d, sp3d, sp3d2, sp3d3, sp3d3. So hybridization, it is interhalogen compound. Interhalogen compound. Type of hybridization. sp3 d we have added, d2 d3, likewise it goes. Structure, what may be the structure? It is said to be linear, t-shaped, linear, it is in the form of t-shaped, square pyramidal, and then pentagonal bipyramidal, square pyramidal, pentagonal bipyramidal. Bipyramidal. How many pairs of electrons are involved? Bond pair and lone pair. Bond pair and lone pair. How many bond pair of electrons and how many lone pair of electrons are present? It is very simple. 1, 3, 5 and 7, odd number. Lone pair will be going in the reverse direction. 0, 1, 2, 3. Let me explain how. Interhalogen compounds are in between A and B. A is the larger one, it is a halogen. Halogen atoms will have how many electrons in the valence shell? 7. If A is at the center, it will have 7 electrons. That means 3 pairs and 1 single electron. 1 s orbital and 3 p orbitals. The electronic configuration will be ns2 np5. ns2 np5. 1, 2, 3, 4, 5, 6, 7. This is the electronic configuration. When these orbitals get mixed, you will be getting sp3 hybridization. In the sp3 hybridized orbital, you will be having 7 electrons. Alright? So, only one lone pair. The structure may be like this: 1, 2, 3, 4. Electronic configuration ns2 np3, sorry, ns2 np5. When s orbital, 1 s orbital and 3 p orbital get mixed, you will be getting sp3 hybridization. In sp3 hybridization, 3 lone pair not involved in bond formation, only 1 electron, odd electron. That electron is making bond with B, that is another halogen, 1 electron of halogen, maybe p orbital, something like that. So this is linear. The bond formed between 1 sp2 hybridized orbital and 1 singly filled orbital of another halogen is linear. Therefore, we get only 1 bond pair, and that is linear, and we say 1 bond pair, 3 lone pairs. 1 bond pair, 3 lone pairs. In the case of AB3, the hybridization is sp3d. How? When it is making bond with 3 halogen atoms, it should make available 3 singly filled orbitals. That's why we set fluorine being smaller in size, more electronegative, it makes another atom to increase the coordination number. Therefore, it may be 1, it may be 3, it may be 5, it may be 7. Here it is 3. How? ns, np, and then we will be having d orbitals. Here 2 electrons, here 1, 1, 1, here 1, here 1. This is the electronic configuration, empty. S, P, D, it is empty. But when it is making AB3, what is happening? 1 electron from here is shifted here to give these orbitals, and these are getting involved in hybridization, said to be sp3d hybridization. sp3d hybridization. Therefore, totally 2, 4, 5, 6, 7 electrons. 1, 2, 3, 4, 5, 6, 7 electrons. 2 lone pair and 3 singly filled orbitals. The electronic structure will be trigonal bipyramidal. 1, 2, 3. Along the corners of a triangle. If I try a triangle, it will go like this. And 1 above the plane, 1 below the plane. And here what is happening? 2 lone pairs of electrons are situated, 1 here and 1 here, 2 lone pair. Singly filled orbital, singly filled orbital, singly filled orbital. Maybe like this. 2, 3. lone pair. Let me write like this. So what is happening? This may overlap with another orbital. This may overlap with another orbital. And one more can overlap with another orbital to give the shape T shape, to produce T shape. And usually with all the electron pairs, it is trigonal, bipyramidal. It may give the shape like this. What is that shape? 1, 2, 3, 4, 5. This is the shape. Now what is happening? Among these, just 2 are bond pairs. Let me consider these 2 as bond pairs. It is because of the, lone pairs. One lone pair, one lone pair. Without getting involved in bond formation, one lone pair. Remaining 3 are singly filled orbitals. 1, 2, 3. These 3 lobes can overlap with 3 B orbitals. B means maybe fluorine, chlorine, something like that. So that we are getting 3 bonds. 1, 2, 3. It is in the form of T. Therefore, we say T shape. Here we have 3 bond pairs and 2 lone pairs. 3 bond pairs, 2 lone pairs. In the case of AB5, just increase one number. This electron will be shifted here. So sp3d2 hybridization. sp3d2 hybridization. So 1, 2, 3, 4, 5. 5 singly filled orbitals, 1 lone pair. It will totally 5 orbitals. Therefore 1, 2, 3, 4, 5, 6. Square bipyramidal. Square bipyramidal. It can be octahedral also. Now what is happening? 1, 2, 3, 4, 5, 6. These are the 6 lobes. 1, 2, 3, 4, 5, 6. These are the 6 lobes. Among them, only one is lone pair. Remaining contain 1 electron each. Those 7 orbitals, 1, 2, 3, 4, 5 orbitals combine with 5 fluorine or chlorine like that. So that we are getting 5 bonds, and the structure seems to be square pyramidal. We are not considering bond pair. So square pyramidal, totally 1, 2, 3, 4, 5 bond pair and 1 lone pair. 5 bond pair and 1 lone pair. Finally, if you go in for AB7, this electron is also shifted here, involved in sp3d3 hybridization. So totally 7 orbitals. 1, 2, 3, 4, 5, 6, 7. All are singly filled. Pentagonal. 1, 2, 3, 4, 5. Pentagonal. 1 lobe, 1 lobe, 1 lobe, 1 lobe. 5 lobes. Bipyramidal, above 1, below 1. Pentagonal bipyramidal. How? Let me draw like this. 5. 1 above the plane, 1 below the plane. 1, 2, 3, 4, 5, 6, 7 lobes. All contain 1 electron each. No bond pair. And these orbitals overlap, no lone pair. And these orbitals overlap with 7 B atoms or P orbitals. To give pentagonal bipyramidal, there is no lone pair. All are bond pairs. Pentagonal bipyramidal. So this is how we get the structure for all the interhalogen compounds AB, AB3, AB5, AB7, sp3, sp3d, sp3d2, sp3d3. Very simple to remember. How do we get the structure? Only 1 electron, singly filled orbital will present. All the 3 are bond pairs, 3 bond pairs. 3 bond pair, only 1 lone pair, 3 lone pair, I am confusing. 3 lone pair and only 1 singly filled orbital. That singly filled orbital makes the bond, it will become bond pair. Only 1 bond pair, therefore linear. All the 3 are lone pairs, 3 lone pairs. If we go in for sp3d, 1 will be shifted, therefore 2 lone pair, and these 2 will become bond pair. Not these 2, 1 more electron will go to D. Therefore, 2 lone pairs and 3 bond pairs you will be getting. 2 lone pairs, 3 bond pairs you will be getting, and it is T-shaped. And it is T-shaped. 1 lobe, 1 lobe, 1 lobe. 3 bond pairs. And if we go in for sp3d2 hybridization, it goes like this. 1 lone pair, 1, 2, 3, 4, 5. 5 singly filled orbitals will make 5 bonds, 5 bond pair. 5 bond pair and 1 lone pair. 5 bond pair and 1 lone pair. It is said to be square pyramidal. Again, if it is shifted, you will be getting sp3d3 hybridization. All become bond pair, no lone pair, and it is pentagonal bipyramidal. That is about structure of interhalogen compounds. With that, we complete the session on interhalogen compounds. Thank you.